This is First Coast Math Clinic with Lesson 4, Solving Multiplication and Division Inequalities with Negative Coefficients for Unit 3, Inequalities, from our Pre-algebra and Algebra curriculum. So the goal of this video is to solve and check multiplication and division inequalities with negative coefficients. In the previous couple videos, we looked at positive coefficients. This video, we're going to look at negative coefficients because there are specific rules that we have to follow when we deal with negative coefficients. So we'll get into that when we multiply and divide by negative values. So we'll get into that. But just a quick review of inequalities. So we know inequalities are mathematical statements with greater than, less than, greater than or equal to, or less than or equal to symbols. And we're going to work with examples that look like something like this. So we've got negative 2x is greater than 10. So our coefficient in this example is this negative 2. We're multiplying the negative 2 times the x. So we want to get the x by itself. Well, how do we do that? All right. Well, we know that to undo that multiplication, we have to use our inverse operation. And we've got to divide by negative 2 and negative 2. Negative 2 divided by negative 2 on the left cancel out. It's just 1 and 1. We don't need to write the 1 in, so we're just going to write x. 10 divided by negative 2, write that a little clearer, is going to give us negative 5. Now, the rule that we have to pay attention to, because we're dividing by a negative, is whenever we multiply or divide by a negative value, we need to flip our inequality. Okay? So instead of this being greater than, our inequality is going to become less than. So we've got x is less than negative 5 as our solution. So that's going to be our answer. So let's graph this and then go through our check. So we've got negative 5. We want an open circle. Negative 4, negative 3. Off to the right. Those are our greater values. Lesser values to the left. Negative 6, negative 7. Now, if our variable is less than our number, remember we're going to shade to the left. We're going to shade towards our minus sign. So for our check, let's pick some values from our solution set where our graph is. So I'm going to pick x equals negative 6 and substitute that back into our inequality. So our original inequality, negative 2x is greater than 10. So let's take that negative 6, put it in for x. Negative 2 times negative 6 gives us 12, and we get 12 is greater than 10, which is a true statement. Okay? So the key thing I want you guys to take away from this problem is because we divided by a negative and divided by a negative, we had to flip that inequality. That greater than became a less than. All right? Let's get into a couple more examples. So number 2, we've got 8 is greater than or equal to negative 4y. We want to get the y by itself. So let's divide by negative 4. Divide by negative 4. The negative 4's cancel out on the right. We're going to be left with 1 and 1. So negative 4 divided by negative 4 is 1 and 1. Again, we don't need to put the 1's in. So we're left with just y. 8 divided by negative 4 is negative 2. Now, because we're dividing by a negative, that inequality is going to go from greater than or equal to less than or equal to. So we've got to flip the inequality. So this is going to be our solution. Negative 2 is less than or equal to y. So let's graph this. Negative 2. I want a closed circle. Negative 1, 0, 1 on the right for my greater values. Negative 3, negative 4, negative 5 on the left for my lesser values. Now, another way we could write this, remember our inequality is opening towards the y, so I could write this also as y is greater than or equal to negative 2. And if our variable is greater than our number, we're shading to the right. So if our inequality is opening towards our variable, we're going to shade to the right. So our check now, we want to choose the easiest value to check usually, and if we've got a 0, that's usually our easiest value to work with. So let's use that. So I'm going to use 0 for my check. So in our original inequality, 8 is greater than or equal to negative 4y. Let's put that 0 in for y. So we'll have 8 is greater than or equal to negative 4 times 0. And 8 is greater than or equal to 0, which is a true statement. And that'll be true for any value that we pick in this solution set. So again, think of like what values we're going to have here. So it's be like 2, 3, 4, right? So if we just keep extending this, and if I decide, well, what if we choose maybe like this 3 here and check that, okay? So if I put 3 back in for y in that original inequality, 8 is greater than or equal to negative 4 times 3, and I get 8 is greater than or equal to negative 12, which is also a true statement, okay? So again, this is just a check to show that any value in this solution set is going to give us a true statement in our original inequality. All right, let's get into another example. So number 3, we've got 2 is greater than or equal to negative y over 3. So now we've got division here. We want to undo this division. We're dividing by 3, so how do we undo division? Well, we multiply, so I'm going to multiply by 3, and whatever I do on the right side, I've got to do on the left side, so I'm going to multiply by 3 and 3. Now, I've got a fraction on this right side, so I'm going to put the 3 over 1. But here's what we need to pay attention to, okay? We've got a negative sign right here. I want to cancel out those negatives. I want to get rid of the negatives. So I can't just multiply by a 3. I've got to multiply by a negative 3 and a negative 3. Okay? Because a negative times a negative is going to give me a positive. I want to cancel out the negatives. So I'm going to multiply both sides by negative and negative 3. It's almost like I'm attaching the negative to that 3. So I'm going to multiply both sides by a negative 3 and a negative 3. On the left side, negative 3 times negative 2 is going to give us negative 6. Now on the right side, we can just multiply straight across and straight across. We know that when we multiply, let me get the highlighter here that I want, a negative times a negative is a positive, so I can cancel out those signs. Y times 3 is 3y. 3 times 1 is 3. Now I'm dividing. 3 divided by 3 is just 1 and 1. So we're left with just y, because we don't need to write the 1's in. And I get negative 6 on the left and y on the right. But now, because we multiplied by a negative 3 and a negative 3, what do we have to do with that inequality? Instead of greater than or equal to, remember, we've got to flip the inequality, so it's going to become less than or equal to, less than or equal to, all right? So since we've multiplied by a negative and multiplied by a negative, we've got to flip the inequality. So our solution is going to be negative 6 is less than or equal to y. So let's graph this. So let's do negative 6 here. We want a closed circle at negative 6. Now remember, we could also rewrite this inequalities opening towards the negative 6, so we could rewrite it like this. Negative 5, negative 4, negative 3 are larger values to the right, lesser values to the left. Negative 7, negative 8, negative 9. Now, if our variable, our inequality is opening towards the variable is larger, variable is greater, so we're going to shade to the right. Okay, so this graph represents our solution. And then for our check, let's pick a value that we can substitute into the original inequality. 2 is greater than or equal to y over, I'm going to attach that negative value to the denominator. Now, remember, just a little piece of information, if we have a fraction like this, negative y over 3, I can basically, if I want to move that negative up to the numerator or move the negative to the denominator, I can kind of manipulate that negative as I want just to make my math a little bit easier. I'm going to move the negative to the denominator just to make my math a little bit easier and make our division a little bit easier. Okay, so we need to pick a y value to check here. Well, what's a good y value to check from the solution set? Let's say I chose -5. Well, if I chose -5, that means, well, I'm putting -5 in for y here, and I'm going to be dividing -5 by -3, and I'm going to get a decimal. I really don't want to do that. The same thing if I chose like -4. I'll have -4 over -3. I really don't want to do that. I want to choose a value that I can easily divide by -3. So remember, when we're doing our check, we want to choose the easiest values possible. So maybe like we could choose -6, or we could choose -3, or of course if we just keep extending this, right? We have -2, -1, and we got 0 out here that we could also choose. So let's do, we got -6. Let's choose that. So 2 is greater than or equal to -6 divided by -3. -6 divided by -3 is 2, so 2 is greater than or equal to 2, which is true. Let's also do second check, -3, so I'm checking the -3. 2 is greater than or equal to -3 over -3. -3 divided by -3 is 1, and 2 is greater than 1, which is also true. Okay. All right, let's do one more example involving division. So for our last example, number 4, we've got -y over 4 is less than -3. So I want to undo this division. So to undo dividing by 4, I'm going to multiply by 4 and multiply by 4. But I have to account for this negative sign on the left side. All right, so I want to multiply by a -4 and a -4 because I want to cancel out these negatives. I know a negative times a negative is going to give us a positive, so I'm going to multiply by -4. So now my negative times negative is a positive. This -4 is over 1. So what's basically going to happen here is my 4 in the numerator, 4 in the denominator are going to cancel out, right? 4 divided by 4 is just 1 and 1. Negative times negative is a positive, so this becomes a positive and a positive, and I'm left with just a y on the left side. And then on the right side, I've got -3 times -4, which is going to give me a positive 12. Now, since I multiplied the left and the right side by a negative, I need to flip the inequality. So instead of less than, it's going to become greater than. So my solution here is y is greater than 12. So let's graph this. So for our graph, let's start with 12. Since it's just greater than, not equal to, I'm going to have an open circle. Larger values to the right, lesser values to the left. So we've got 13, 14, 15, and 16 on the right, 11, 10, and 9 on the left. Y is greater than, since my variable is greater than my number, I'm going to shade to the right. All right, so everything that's shaded is my solution set. Now for my check, we need to pick a value in our solution set, substitute it back in to our original inequality, and check our answer. Now, whatever we substitute in, we're dividing by 4. So think about like we're substituting a value in for y. Whatever we substitute in, we're going to divide by 4. Well, what's a good choice, right? We could substitute 13, 14, 15, 16, 17, 18, any value in this range, right? That's going to be larger than 12. Well, 13, 14, 15 isn't divisible by 4, but 16 is. So I'm going to choose 16 as my y value. So the way I'm going to rewrite this, I'm going to attach that negative to the denominator. And I'm going to rewrite this as 16, substitute the 16 in for y. And I'm just going to bring that negative value into the denominator, because we can manipulate this. If I have a negative in front of the fraction, I can move it to the numerator, I can move it to the denominator. So now I've got 16 divided by negative 4, which is negative 4 is less than negative 3. And negative 4 is less than 3, which we know is true, right? If we would graph this out. All right, so 0, our negative values to the left. All right, the further left we go, the smaller our values get. Negative 4 is further left than negative 3, so this is true. Negative 4 is less than negative 3, so our solution, y is greater than 12, checks. All right, so this was lesson 4, solving multiplication and division inequalities with negative coefficients. If you like this video, leave a like, comment, and subscribe. First Coast Math Clinic.